So in this next module, we're going to talk about the introduction section. So after you've written your tables and figures and your results and your methods, then you're ready to write the introduction. And the good news is that the introduction section is actually a lot easier to write than you may realize. So it follows actually a fairly standard format. So there aren't so many different ways that you can write that introduction section, which makes it easier. It's also fairly short. The typical introduction section is only 3 paragraphs long. Now, you may not have realized that before. You may have thought it was much longer than that. Generally, I recommend for an introduction section no more than 5 paragraphs, so somewhere in the range of 2 to 5. And again, probably the most typical is 3. So the biggest mistake that people make when they're writing the introduction section is that they think it's supposed to be some kind of long, exhaustive review of the general topic. You've gone through your PubMed, you've gone and collected all of these papers, you've done all this great literature search, you've read up on the topic, you've got so much information. So you may feel like, oh, I've got to, impart all of this information I've collected, I've got to impart it in the introduction. But that, in fact, is not the purpose of the introduction. The introduction section is focused around a very specific question, the very specific question or hypothesis or aim of your study. And you shape the whole introduction section around that question or hypothesis. And so, for example, if you're writing a paper, you did a study on breast cancer and smoking, the link between breast cancer and smoking, you wouldn't write a whole bunch of background information about breast cancer, how bad it is as a disease and what all the causes are and all of that. You don't need to put any of that in the introduction. Similarly, you wouldn't put anything in about just in general how bad smoking is. You're not going to spend a lot of time on that saying all the other diseases that smoking links to. You're going to quickly focus right on what is the potential relationship between specifically smoking and breast cancer. And you're really only going to talk about previous studies that have addressed that specific question. So it's a very narrow section, which actually means it's a little bit more, there's only so many ways you can do it. It's pretty standard, and I'll give you that standard format, and you'll see that it's actually not that hard to write. So a really good way to think of the introduction is as a cone, as is pictured here. This is a figure I borrowed from one of Thomas Ansley's papers. I mentioned the series in clinical chemistry. Again, a really good series to refer to. But he draws this nice little cone, and the idea here is that you're going to start with something general, and you're going to narrow down very quickly to your specific study. So you start your introduction by giving a quick little bit of background, context, don't spend too much time on that, and giving specifically the what's known about your hypothesis or question of interest. I'll give you some examples in a minute, but it would be something like, here's a little quick summary of all the other studies that have been done on breast cancer and smoking. Here's what they found. Then you quickly move from the what's known to the what's unknown. So you quickly move to what are the gaps and limitations of all those previous studies that look specifically at smoking and breast cancer. Then you narrow down rather quickly, even further, to your specific hypothesis or question or aim of your study. And you actually want to have a clear statement in the introduction section, towards the end of the introduction section, that says, we hypothesized that. We wanted to answer the question of. We aimed to. And it's good to use that explicit language with those little key words in there. We hypothesized, we aimed. Because sometimes readers will just skim the introduction and they're looking for that. They're looking for that statement of what the purpose of your study was. So you quickly tell them what the main hypothesis or aim of your study was, and then you tell them a little bit about your experimental approach. And you're going to say, how is your experiment looking at breast cancer and smoking different and new, and how does it fill in the gaps and limitations of all those previous studies? So why did you need to do your study, and how are you going to improve on all those other studies to answer your question of interest? Similarly, Mimi Zeiger, in her book that I've referred to before, she gives a similar structure for the introduction. So she says you start with what's known, so those are the previous studies. Then you give the what's unknown, the gaps and limitations in those previous studies. And then again, you move right to the specific statement about your purpose or question that you're trying to answer, or hypothesis or aim. You're going to give that clear statement. We aim to, we hypothesize that. And then you give a little teeny bit about your experimental approach, and you say why your experimental approach is new and different and important. In other words, how does it fill in the gaps in the previous literature, in those previous studies? And you can kind of think of this as roughly 3 paragraphs, right? So paragraph 1 roughly could be the what's known. You don't always have to structure it this way, but you can see how this kind of naturally fits to 3 paragraphs. Paragraph 2 could be the what's unknown, the limitations and gaps in previous studies. You'll see that sometimes authors will switch between the what's known and what's unknown, and might have that in multiple paragraphs, but you can kind of see why this often ends up as 3 paragraphs. And then all of that last part, the question statement and your quick overview of your experimental approach and how your study fills in those gaps, that can be a 3rd paragraph. So that's often roughly how it falls out. Now, it doesn't mean you always have to have 3 paragraphs, but this is a good way to organize it. So a couple tips for writing an introduction section. So one is, I've told you it's only about 3 paragraphs, so you might think, well, then I've got to have these really long paragraphs. No, I actually mean 3 short paragraphs. So these don't have to be super long. They, in fact, should be nice and crisp and short. So keep your paragraphs short. Try to write as much as you can for a general audience. So technical details are going to have to appear in your manuscript, of course, but leave those for the technical section, for the materials and methods. The introduction is supposed to be a friendly introduction to what you did in your study. So there's no reason to fill it up with jargon and technical material. Really keep it clear and concise. And again, as I've shown you in the previous slides, you want to kind of take your reader step by step from what is known to what is unknown to your specific question or hypothesis. So we already kind of outlined that. I'm just going to repeat it because it's just such a nice way to put that known, unknown question. You want to, again, emphasize how your study fills in the gaps. So make sure you say specifically how your study fills in the gaps of the unknown, the previous literature. What's the unknown? And again, explicitly state your research question or aim or hypothesis. So say, we asked whether, our hypothesis was, we tested the hypothesis that, our aims were. So in other words, as I mentioned before, your reader might skim your introduction and just look for that statement. I often do that when I'm reviewing papers. I kind of want to know exactly, well, what was their primary aim here? I'm skimming the introduction looking for that statement. So make sure it's there and it's very clear and easy to find. The introduction section is not the place where you answer your research question, so you're not going to put results or implications in the introduction. It's really setting up that question and then ending there. And similarly, you don't really want to put too many, you want to say a little bit about your methods because you're giving an overview of your methods, but you're not going to put too much detail about your methods in the introduction section. Another tip for the introduction section, one thing that people tend to do wrong is that again, you've done all this literature research, you now know all these details about all these different studies, and there's a temptation to go into nitty-gritty detail about each study. Like you'll want to say, well, Jones et al. Did this case control study, but the problems with that study were X, Y, and Z, and then Smith et al. Did this cross-sectional study, and the problems with that study were blah, blah, blah. So there's a temptation to want to go kind of through all the different studies that are out there in great detail because you've done all this research and you know all these details about these different studies. So you're going to be tempted to put it in. But it actually doesn't belong in the introduction section. You're going to see in the examples that I give you in a minute that for the most part you're going to summarize at a very high level. So rather than getting into the nitty-gritty details of specific studies, you're going to say, well, here's the 5 studies that were done, on breast cancer and smoking, and here's what they generally found. So you're going to summarize at a very high level. So you're going to leave out specific, detailed descriptions of particular studies. They don't really belong in the introduction unless your study was really, addressing one particular study. I mean, there could be the case where you're trying to replicate a particular study that came before you. Then your introduction might focus on that one study. But in general, if you're covering a whole bunch of studies in your introduction section, you should summarize at a high level. You might go into some more details about those particular studies in your discussion, but that really belongs in the discussion section. All right, so let's jump into an example introduction section. I'm just going to kind of go through it and show you. Notice, first of all, that this is only 2 paragraphs long, and it was really easy for me to pop into a single PowerPoint slide. So that tells you that the introduction section, again, is fairly short. This is a particularly short one. but they're all close to this. They're not long. So let's kind of go through this, and I'll show you all the elements that I was talking about. So first of all, this was about potential risk factors for asthma. So they start with the what's known. Notice they jump right into their question of interest. Notice they don't give you like, well, asthma is an important problem. It affects a lot of children. We kind of all know that. So there's not a lot of kind of those high-level background information here. They just jumped right into what's known about their question of interest, which is what causes asthma. So they say exposures to secondhand tobacco smoke, road vehicle traffic, and diet are some of the most prevalent, potentially, these are the potential risk factors and modifiable risk factors for asthma in children. So here are 3 things that other people previously have speculated are causes of asthma. Now, one of those we know with pretty good certainty. So the effect of parental smoking on asthma is well established. So that one we know pretty well. However, now we're going to get to the what's unknown. The evidence for whether or not the road vehicle traffic and whether or not the diet and what elements of diet, the evidence there is a little bit less clear. So some studies have found that road vehicle traffic is a risk factor for asthma. Others have not found that. So there's some controversy. There's some unknown here. Also with diet, some studies, some dietary factors have been linked, but it's kind of unclear exactly which ones. So that's the unknown. Then we get back to a known. Sometimes you'll notice that authors will switch between the known and the unknown, and that's okay. That they do know one particular dietary factor that seems to be consistently linked to asthma is fruit intake. So we've got sort of all the background, then what's known and what's unknown. Notice that the authors didn't give us any particular details about any of those studies 1 through 13 that they're summarizing there. They just give you the high-level summary. Here's studies that found a link, here's studies that didn't. Now we're going to jump right into the aim of this study. So what do they say? As part of an evaluation of the health benefits of this scheme, we have taken the opportunity to investigate, notice the key word there, and investigate the relative importance of fruit intake, exposure to secondhand smoke, and road vehicle traffic, those 3 risk factors, in determining the prevalence of asthma in over 11,000 children. So they're telling you, here's our question and aim. We're going to look at those 3 risk factors in a really big sample of children. And it's a very clear statement of the aim of their study. Now, there's one thing I think that this very short introduction section is actually probably missing. Notice that they didn't explicitly tell the reader how this study is going to fill in the gaps and limitations of the previous study. So they don't tell you, how come this study is going to get it right when there's been controversy, especially about road vehicle traffic and diet in previous studies. So it would have been nice to have some explicit statement of that. You can probably make some guesses here, though. This is a study of 11,000 children. I bet that a lot of those previous studies weren't so big, and so maybe they think the real strength is in the size of their study. It would be nice if they give us a little bit more in terms of why is their study better. All right, so here's another example. Notice again that this one is only 2 paragraphs long, slightly longer than the last example, but still only 2 paragraphs. So this one was looking at whether or not obesity and overweight was related to mortality from cancer. So they start with the what's known. So what do we know? So we know that if you're overweight or obese, that's been linked to death from all causes as well as from heart disease. That's well established. We also know that there's some relationship between being overweight and obese and death from cancer, but there's a whole bunch of gaps in that. So here's the unknown. We don't know the magnitude of that relationship for all cancers or for cancers at individual sites. So we may know that kind of overall it's linked to some cancers, but we don't know exactly which ones. We don't know how big that is, and we don't know what the public health effect is in terms of total mortality from cancer. So then they jump back to what is known. So we do know some things about some particular cancers. So we do know that your adiposity is linked to some cancers, endometrium, kidney, gallbladder for women, breast for postmenopausal women, colon for men, esophagus. However, they're jumping back now to what's unknown. There's these other cancers, pancreas, prostate, etc., prostate, liver, cervix, etc., are actually the data are scarce or inconsistent. Notice how many studies they're citing here. They're citing a whole pile of studies. So they're giving you a very high-level summary saying, well, we've got all of these other studies on these other cancers and we don't have a consistent result. That is, some studies may show one thing, some show another, or there just may not be many studies on those particular organs. Now they're going to specifically say the gaps and limitations in the previous studies. So here's a bunch of things that were wrong with the previous studies, which may be why they were inconsistent. So one is that there's, first of all, a limited number of studies. So some of these cancers may not have been well studied at all. And that's especially true that there are not that many studies that were prospective. And it's very important to be prospective when you're studying these kinds of things. There was also different ways that people categorized overweight and obesity. There was some potential biases introduced by smoking. And people didn't do a good job maybe in these previous studies of always separating the difference between getting cancer and dying from cancer. And they specifically want to know about dying from cancer, not just about cancer incidence, that is getting cancer. So those are all the gaps and limitations. They've nicely kind of lined them out for you. And then they get to their statement of their question of interest. So what do? We conducted a prospective investigation in a large cohort of U.S. men and women to determine the relations between body mass index and the risk of death from cancer at specific sites. So this is both a statement of what their aim was, they want to determine this relationship, and what they did. They ran a prospective investigation in a large cohort. And they also tell you that this cohort's been used previously, so they're kind of verifying that this is a good data set. They're looking at BMI rather than just kind of arbitrarily categorizing overweight and obesity. They're looking at all these different cancers. Their investigation is prospective. So that's all the ways that they're doing better than the previous studies, and they're hoping to be able to answer some of these questions. All right, so moving on to yet another introduction. So I told you that introductions are typically three paragraphs long, and the first couple examples I have in here are actually only 2 paragraphs long. But you can see, again, you can fit a whole introduction on a PowerPoint slide. So this one was looking at a question in systems biology. So they start with giving you a little bit of background and some of what's known. So one of the most intriguing findings in system biology is that despite the varied constituents and metabolic pathways, the metabolic networks exhibit the same scale-free organization. So they define that for you. That is, a small part of metabolites participate in a large number of reactions, termed hubs, while others are involved in only a few reactions. So they kind of go in, they give you a little bit of terminology here, because this, in case you're unfamiliar with this. So then they tell you that the scale-free organization of these networks has been hypothetically explained in terms of evolution, that the new recruited metabolite members attach preferentially to those that are already well connected, so the rich get richer. So there's this idea that the hubs, that the newly evolved metabolites are going to kind of attach onto these hubs. This implies that the metabolic network hubs originated relatively earlier than others in evolutionary history. So here's some known and some kind of what people think about this topic. Now here's the unknown. However, several issues about this evolutionary explanation that other people have posited remain elusive. That's a nice statement to tell you, hey, I'm about to tell you the unknowns and the gaps here. So here's all the gaps. First, the molecular basis of preferential attachment principle has not been fully elucidated. So we don't really know exactly how new metabolites would know which metabolites are well connected. How would they kind of know that in evolution? And second, the evolutionary explanation to the metabolic network organization has little implications for network design, so that is, even if we understood this well, we might not necessarily be able to use it for network design. So there's a kind of some unknowns. And then when they get to their study. So notice that nice statement, we speculate that, that's the reader's clue that they're about to give their research question statement. So we speculate that the metabolic network organization may have a chemical basis, which stimulated our interest to address these issues by combining bioinformatics and chemoinformatics. So their novel approach here is to combine bioinformatics and chemoinformatics, and they actually give you a definition of chemoinformatics in case you're unfamiliar with it. But again, they go from known, unknown to their specific study, and that nice statement of we speculate that. All right, another example. This one's actually 3 paragraphs long. So this one says exogenous estrogens, so these are if you're taking estrogen pills, prevent or substantially retard the decrease in bone mineral density that accompanies menopause. So we know if you give estrogen pills to postmenopausal women that will stop them from losing bone density. So that's the known. However, what we don't know, and what this particular study is interested in, is whether or not if you give exogenous estrogen in the form of oral contraceptives, which are estrogens, whether or not that can affect bone density in young women. And they kind of give you here a quick review of all the literature that's tried to answer that question. So several studies suggest that using oral contraceptives during the premenopausal years helps your bone density, whereas other studies have shown no effect. Notice that there's a summary here of about 17 different studies, and there's no details about those individual studies. It's a high-level summary, just kind of giving you the scope of the literature. A lot of studies show some positive benefits, some show no effect. Now here's the gaps in those previous studies. So past studies have had several limitations. Some of them have focused on crude measures of oral contraceptive use, such as current, past, and never, rather than measuring it carefully. Many studies have failed to take into account potential confounders, lifestyle effects, and finally, few studies have looked at oral contraceptives and bone mineral density in women of races other than white. So those are the gaps. And what's this study going to do? Well, the aim of this study, so notice we're giving the clue to the reader, that's your statement of the research aim. The aim of this study was to evaluate the associations of oral contraceptives with bone mineral density in both black and white premenopausal women. And then there's a hypothesis statement as well. Our primary hypothesis was that there would be an association between a cumulative exposure measured to estrogen from oral contraceptives and bone density. So there's a number of ways that they're saying here that their study is going to address the gaps in the previous literature. All right, another example. This one's also 3 paragraphs long. So this one was talking about looking at flowers that are a byproduct of the oil industry. So they give you a lot of kind of background here because you may not be familiar with this whole process, so they give you some nice background and they tell you the what's known. So defatted flowers are a byproduct of the oil industry, and in fact those flowers that come out when people are extracting oil, such as from sunflowers, those flowers tend to be high in protein. So they're a good source of protein. In 2009, Argentina was actually the second largest sunflower oil producer in the world. Presumably this paper is coming from Argentina. And the largest exporter of sunflower refined oil and oil cake. Now oil cake here I think is just the flour. Among sunflower oil manufacturing byproducts, the sunflower oil cake is underused, being almost exclusively employed for animal feeding in spite of its high content of highly digestible protein. So these are potentially, again, a really good source of protein for people. But the concern has been that there's a lot of phenolic compounds in these oil cakes, these flours. And people have to extract them. They've thought that they had to take them out. And that's the main reason that people haven't used these sunflower flowers before, because they were worried about having to take out these chemicals. Also, these compounds reduce the protein solubility and cause some bad things. So, and different methods have been invented to remove these compounds, or been proposed to remove these compounds. So there's different things people think might remove these compounds. So that's a lot of background and the what's known, and then we jump, however, to the what's unknown. And actually, this one's a little bit more of a controversy. So they're setting up the unknown is really a controversy here. So in parallel, however, in the last few years, notice the author's kind of cluing you in that they're changing modes here because they get that however. In the last few years, there's been increasing interest in keeping these phenolic compounds and even in adding them into formulations because they have antioxidant activity. So there's some belief that the antioxidants from these phenolic chemicals may have benefits for health. So now there's a controversy. So maybe we should actually not bother to remove these compounds from these protein flours. Maybe we should leave them in these sunflower flowers. So there's kind of a controversy here. And what's this study going to do? Well, this study aims to help answer that controversy, and they give you some very specific aims, and sometimes if you've got more than one aim, it's great to list them with numbers as they have done here. So the aims of this study were, 1, to develop methods for obtaining from the residual pellet sunflower protein concentrates and isolates with different contents of phenolic compounds. So they're kind of just getting a method for getting those phenolic compounds out. And 2, to assess the effect of such compounds on the antioxidant capacity of the product. So they're kind of trying to help answer that controversy by adding some information, by answering those particular questions. All right, one last one. This one's also 3 paragraphs long. So this one was on road traffic collisions, whether or not you could prevent those by putting in traffic speed cameras. So these will, kind of take a picture or capture your speed when there's no actual cop there, and will say, hey, you were speeding, and send you a ticket automatically in the mail. For obvious reasons, these are somewhat controversial. So we get a kind of a statement of the problem and the what's known. So they give you a little background about, traffic collisions on the road are an important source of mortality and morbidity worldwide. Little kind of background information. And then they get into the specific question of interest here. So measures to reduce traffic speed are important because we know that if you can get people to drive more slowly, that you will reduce the number of deaths, road traffic fatalities. So, but what's kind of, and what's happened is that people have then implemented speed cameras to help reduce speed traffic because they believe that that's going to ultimately save lives. And this study was specifically in the United Kingdom. So that's the what's known. Here's the unknown, and also here it's sort of a controversy too. So the unknown is we don't really know. We kind of know if you slow people down that you're going to save lives, but we don't know if the speed cameras really help. So maybe people, maybe because you're not getting an immediate feedback, you're just getting a ticket later on, maybe it's not going to slow you down overall. So maybe these actually don't help. And of course they're controversial because for obvious reasons people probably don't like them too much. So they're saying that there's a lot of controversy here, and the problem is nobody has any really good evidence to say whether or not they actually work. So there's lack of reliable evidence available on their effectiveness. So it's hard for people to have an informed debate when you don't have that kind of evidence. And here's the limitations of previous research. Well, there hasn't been much research, and there was one small non-systematic review previously that looked at 6 studies. They did find a 17% reduction in collisions after the introduction of speed cameras, but there was probably a lot of problems with this study because it was non-systematic review, and they tell you why non-systematic reviews might, be biased. So what did they aim to do in this study? So we aimed, therefore, to systematically assess the evidence for the effectiveness of speed cameras. So they're going to do a systematic review, and that's going to improve on the non-systematic review that was done before, and try to tabulate the total evidence available about whether or not speed cameras really do reduce road traffic collisions and related casualties. So that's the introduction section. Again, usually about 3 paragraphs long, maybe 2 to 5 paragraphs. You start with what's known, you go to what's unknown, the gaps and limitations, the previous studies, and then you state explicitly what you're going to test, what question you're trying to answer, what hypothesis you're trying to test in this study, and how your study is filling in the gaps and limitations of the previous literature.
The preceding program is copyrighted by the Board of Trustees of the Leland Stanford Junior University. Please visit us at med.stanford.edu.